Hi, we are Team Zero. We have four members of Wongun, Donghyun, Seunggun, and Zian. Let me start by asking a question. Have you ever had trouble deciding what to eat? As we already know, choosing what to eat is difficult, even with quick delivery apps and web services. This is because there are so many things to consider. Some menus that may be not available, and you may not like some other menus to be your next meal. Because everyone has different priority, we have to compare multiple factors and select the most appropriate menu. We are addressing this problem by presenting an AI meal planner, which helps the user to do the decision-making process much faster. Our service targets three different types of user experience: ordering a food delivery, going out to eat, and cooking. The user will be given the most appropriate restaurant or recipe after the system analyzes various kinds of decision factors, which will be specified in the next slide.
We will look at the determinants for satisfying three different types of UX, which means user experience. The factors that a meal planner needs to determine the recommended food type are as follows. First of all, there are user presets here. By knowing the user's preference in advance, AI planner will provide better satisfaction. Next, health condition. Based on the user's current health condition, it determines which foods to avoid and which foods to supplement. Through this, users can be provided with a more healthy diet. A recent meal history is also an important factor. Most people will be reluctant to eat what they ate for lunch again for dinner. Foods eaten in the near past are excluded from the recommendation list by viewing the cart transaction records. Foods already in the refrigerator are also determinants. If there is a lot of food in the refrigerator, it is recommended to cook and eat. In addition, it can guide the recommended route when eating out by identifying the location of the house, and referencing the rating of the restaurant helps users to have a more satisfying dining experience. Based on the weather information and traffic information, AI meal planner can exclude eating out from the list of recommendation on rainy day or heavy traffic jam. Next, the stakeholders. Users can be classified according to their size and properties. It can be divided into single-person households and multi-person households, users who demand accuracy, users who want to solve laziness, and users who prefer healthy diet. Developers, restaurant owners, credit card companies, hospitals, etc. can be stakeholders. Next, the elements that make up our services. Let's start with IoT devices. Basically, our service can perform most functions with one smartphone. Since everyone has a smartphone, this feature is very advantageous in terms of availability. If users want to further improve the user experience, users can connect and use additional IoT devices according to their own choice. The smart speaker makes voice communication smoother, and a smartwatch and bracelet makes touch-based use convenient without having to carry a heavy smartphone every day. Smart refrigerator allow you to take advantage of the cooking assistance system even more. For the first release, we will only service these three IoT devices. We plan to gradually increase the number of supported IoT devices after securing stability by focusing on only three IoT devices. Next is web resources. By storing and managing various web resources in the database, AI Meal Planner can create a better food recommendation list. Weather information, traffic information, location information, payment information, hospital records, delivery information, natural language processing, and translation function are the components of the web resources. Finally, cloud sources. Amazon Web Service is the most widely used cloud service. Therefore, its stability has been guaranteed to some extent, and we will adopt AWS as our database. The algorithm that is most important is made by ourselves, and plan to provide a food recommendation list by processing the information in the database.
Our requirement elicitation was divided into three parts: brainstorming, storyboarding, and interviewing. Brainstorming was already done for the proposal, to generate as many ideas as possible, as we explained so far. And then, using the scenarios that we constructed for the proposal, we made storyboards to help users visualize the app features in the next step. Interviews. The interviews were the main part of our requirement elicitation. In this stage, we tried to find additional needs, prioritization, and filter out any unnecessary ideas. A worker went back home tired and hungry. He just wanted to get some food as soon as possible. As usual, After spending 15 minutes going through all the restaurant's menus and check all the coupons he's got, he felt irritated and shut down the delivery app eventually. However, with the presence of our system, in lazy mode, he got food delivered as quickly as possible. Or, in conversation mode, he elaborated his requirements to the AI and got food too. A young man wanted to dine out, but he hesitated at choosing the restaurant in his neighborhood. After wasting 20 minutes wandering the streets, he randomly ran into a restaurant that he doesn't like at all. However, with the presence of our system, in lazy mode, he went to a sushi restaurant that he liked very much. Or, in conversation mode, after telling AI that he doesn't want to walk much, he chose to go to the nearest restaurant. A young woman wanted to make French toast at home. She's on a diet, but she had no idea what's good for her exercise plan. Browsing the web didn't actually give her any clear guidance. However, with the presence of our system, in lazy mode, she decided to make salad by AI's recommendation and actually made it under careful guidance from AI. Or in conversation mode, she wanted to make something out of bread, and after some conversations with AI, she decided to make salad because she's on a diet.
For the interviews, we conducted separate interviews for separate tasks. So we conducted 3 to 4 interviews for each of the tasks: ordering food delivery, going out to eat, and cooking. We had a total of 10 interviewees. We only selected people who engage in that particular task very frequently, or at least once a week. Here's the general outline of the interviews. First, in order to identify any needs we might have failed to consider in the proposal, we asked questions about the usual experience when performing that particular task. For example, when we were interviewing about ordering food delivery, we would ask, which factor do you consider most important, or which multiple factors do you consider most important when choosing what to order? What kind of problems or inconveniences have you experienced while ordering food delivery? And then we showed them our storyboards and explained our app idea. We asked what kind of issues that they might experience while using the service. We also asked if they relate more with the lazy mode or the conversation mode, as we explained in the storyboards. These questions would help us choose whether to focus on the convenience aspect or the personalized customization aspect of our app. Finally, among all the possible information that the app can use to make personalized suggestions, we asked which of these information they were willing to provide. For basic information like dietary restrictions, budget, and location, we expected everyone would provide it. But more sensitive information like health vitals, payment history, and medical records might be too controversial. So based on the results of the interview, we would filter out some of this information from our app. Here are some of the significant findings after compiling the results of our interview. Decisiveness was a common problem for ordering food and going out to eat, as we expected, but for people who cook, this wasn't much of a problem. We concluded that simply helping to choose what to cook wouldn't be enough to garner users for the case of cooking. Another thing we failed to consider is that reaching a consensus among a group of people is a big issue, especially when going out or cooking. Most people preferred conversation mode, which means they value personalized customization aspect more. However, some people preferred lazy mode when deciding with a group of people. Many people said that the voice lines were awkward, and it was confusing which voice lines would trigger lazy mode or conversation mode. Finally, for the willingness to provide information, quite a few people were willing to provide all the information we mentioned. It was around 50-50. A lot of people were worried about privacy, as we expected, but some people were willing to provide everything as long as it was effortless to provide it. From these findings, here are changes to the requirements that we decided on. First of all, we would add features to consider multiple people's preferences when deciding on a meal. We will allow multiple users, family members or roommates, to be registered into one account. Also, smart speakers should be able to have a conversation with multiple people at once. As for the cooking, the app should be able to plan future meals so that ingredients can be automatically ordered in advance. We should also define specific voice lines that trigger lazy mode and conversation mode in a less awkward manner. Finally, we won't be filtering out any information from our app, but we should make sure that the app can directly collect all the information without much work from the user. So there should be seamless communication between our app and external actors like banks or hospitals. Also, we can use smartphone sensors to automatically collect health vitals from the users, like heart rate and sleep condition. Using these elicitation results, we formulated 3 use case diagrams, one for ordering delivery, one for going out to eat, and one for cooking. The first diagram is for food delivery. On the left side of the diagram, you can see different types of users represented as actors. The primary user can register his preferences to the app, such as dietary restrictions or budget. Roommates and family members can also register their own set of preferences, assuming that they regularly eat meals together. The user, roommate, and/or visitors should be able to request the app for menu suggestions in either lazy mode or conversation mode, as explained before. Then the smart speaker will make a menu suggestion. All the other use cases connected with include or extend relationships are factors that will be considered when making a suggestion. Include use cases are required tasks, while extend use cases are optional. Every time an app makes a suggestion, it should check any user preferences, it should check the location, and it should browse nearby stores and menu of the delivery app. All other information such as health vitals and payment history are optional. Finally, if a decision is made, then the app can automatically place an order. The use cases in the green box are specific to food delivery. The rest of the use cases are common for other cases like going out to eat and cooking. As you can see, only the contents in the green box is different for the use case of going out to eat at a restaurant. Instead of using the food delivery API to find stores, the system this time will find nearby locations using a map API. After the decision is made, the app can also provide users with directions on how to get to the restaurant. In the case of cooking, the app will look at the contents of the smart fridge to make menu suggestions. After the decision is made, the app can also provide a recipe to make it easier for the users to follow the steps when cooking. An additional feature for the case of cooking is that the app will be able to order ingredients automatically online based on predictions of future menu by processing user preferences and past meal history.